Hi, welcome to the pre-calculus lecture series. In this video, we're going to talk about section 2.2. And in this section, we're going to take a look at different graphs for the different functions. And we're going to introduce 6 different graphs in these sections here, basically. So every time when you see that, you can recognize, oh, this is, we call this the power function graph. This is, we call this roots graph. And then in the later chapters in the pre-cal, we're going to go deep on each one of those functions here, all right? So right now, we just basically get a kind of idea of what is the function looks like, and then what type of the typical like standard form we're going to have. So when we talk about the transformation for the different function later, so we know, oh, this is, we use the parent function for quadratic, for examples here, all right? Then we're also going to talk about, we're going to introduce, we call this a vertical line test. And so from the vertical line test, we'll be able to see if you give me a graph, is this graph represent a function or not? Okay, so now I'm going to go to the, I'm going to go to the worksheet, the lecture notes here. And so in here, we're going to start to introduce some functions here, all right? So the first functions here, the graph of functions, right? So we're going to talk about the first one is the linear function. This is the most common functions we're going to talk about. So the general form is y equal to the mx plus b. I think most of you should learn that from your pre-cal, or I'm sorry, from your algebra 2 or algebra 1 classes, right? So the linear functions here, we have like 3 kinds of the linear functions. And okay, so for these ones here, if you only have like, you have a function like this, this is like, we call it, this is a constant function here. Okay, so this is a constant function. That means y over the f of x is equal to what? Is equal to a constant. Here is a constant function. And then the next ones here is, we call this is the 1. So it's the diagonal. So this is the diagonal to the, to here. So this is, we call this the identity function. Okay, so this is the identity functions. Then the function form is, we say, is y equal to the x here. And the identity function really is also is the parent function for the linear functions here, all right? So then the next ones here is a linear function. So linear function will just be in the general here. This is the, we call this the linear functions, right? So this is in the general form. So this function is mx plus b, right? So what is the b's here? B is this, so this is y-intercept, right? So this b is here, this is the y-intercept. Okay, so this is our first set of the function. Okay, so now let's take a look at our next set of the functions here. And we call this the power function. Okay, so, or some people call you can call this is the polynomials, right? So the in general form, they will write as y equal to f of x, then is x to the nth power. So you can call this is a polynomials also. So we have a few things here. So the first things here, this is the 1. This is also we're very familiar with. So this is what we call this the what? So this is the quadratic, right? So this is a quadratic functions here. Let me erase this line a little bit shorter. Oh, I got okay, so this one's here. Okay, so this is what we call this a quadratic function. right? So quadratic function, so it's like it's the second power, y equal to the x squared. So also for the quadratic function, this is the parent function. Okay, so this is the parent function for the quadratic also. Then for the cube functions here, let's take a look at few, because those are the few we're going to experience that. So the cube functions is something like this. Okay, so this is, we call this a cube function. Okay, so this is a cube functions here. And then the cube functions, we write as y equal to the x cubed. So also later when you try to use the transformation, this is also, it's the parent function for the cube function. And then like in here, so in general, like in here, if you have like a f of x here, I'm just trying to find, this is the f of x, if this is the x to the fourth, all right? So the x to the fourth is still very similar like the quadratic, but in here, they just have a little bit of kind of go like here, go, it's like, right? So in here is kind of like the little bit sharper here, but here we have like a little bit flatter than that. So like you can see, you know, if I have x to the n, then it's still the both ends will go up here, all right? So the same ways here, if we take a look in general, right? So if this is the x to the fifth, right? So y equal to x to the fifth. So it's the same way, you know, like in here, the functions go like a little bit flat here, and then did it flat here and going down. So instead of go down like here, so this is the y equal to x to the what? The fifth. So as you can see for the polynomial here, right? If it's odd, so if the n's here, so if n's here is odd number, so you're going to have one end go up, one end go down. Now, if the n is even, then what happens here? That means that both will go up or both will go down here. All right. Okay, so now in here, let's take a look at the next ones here. The next functions here, we're going to take a look at the root functions, right? So this is also is a very common function, and we're going to go over all those functions later. So the root function is kind of like the inverse of the power function. So it's y is equal to the f of x, and here this is x to the nth roots here. Okay, so for the nth roots, and so the first things here, let's take a look at the square roots, right? So for the square root function, so that means it will look like this, right? Because the square roots, you cannot have negative inside, right? So this is y equal to the square roots function. And this will be, you know, this will be the parent function we're going to use, right? Later when we do the transformation. Okay, now, like how about if you have a cube roots here? Okay, so look here, right? So this is the cube function. Then cube roots here is kind of like, because they are inverse, you kind of bend over. So the cube roots will go like this. Let me see here. Okay. So the cube roots will go like this, kind of, you bend this one down. Then what happened here? You bend this one this way, see here. So this is what we call it the cube roots. So it's y equal to the f of x equal to the cube roots here, right? Okay, so the same way, if you have like, you know, the same way if you have like the roots getting bigger, and I don't want to say bigger. So if this is y equal to, so if this is the, okay, so if this is y, so if this is y equal to the fourth roots, because you know every time if it's even roots, so here you need to be careful. If it's even roots, right, so you cannot have negative, so it's always going to be on the positive side. So the fourth roots here is just like in here, you have a little bit of kind of a flatness here. So in here, the same, you can have a little flatness here. Then this is, so we call it the fourth root. So the same one, if you take a look at the fifth roots here, so the basic shape will be very similar, right? So the fifth root, so if y is equal to the x to the fifth, and so you're going to go two ways, right? But then here, just like in here, we have a little bit of flatness here, right? So it will go like something like this. Right, so you have a little bit of flatness here, right? So that's what we call this, the root function. So the purpose here for this section, basically just want to get you an idea what is the function looks like. So like in your homework, so they will give you function, they will ask you what type of function is this. So we're not going into the detail about the characteristic, those things. We just say, hey, this is the shape of the functions, right? Okay, so then the next things here, we're going to talk about is the reciprocal function. Okay, so the reciprocal function, like I said, we're going to spend the whole chapter to talk about that. So the reciprocal function is something look like this. Y is equal to 1 over xn squared. I'm going to run out of the space for the note area. I hope that you have enough space when you take notes here. Okay, so reciprocal. Okay, so the first one here is this one. Okay, so the first one will be if you have y is equal to 1 over x here. Okay, so then your graph will looks like something like here, right? Because when x approach to 0, it will go into the infinity, and when x approach to infinity, it will go to zeros, right? So maybe I can graph this one a little better. Okay, so this one's here will be kind of like this and this. All right. Okay, so now let's take a look. How about if I have 1 over x to the square here? Okay, so this is 1 over x to the square. So for this one here, because it's a square, so basically I don't have the negative anymore, right? So basically you're going to have a curve like this. Then this one going to go boom because it's a square, so become positive. So this will be the function looks like this. And then the same way is if you have like the cube or, you know, the fourth, the shape will be similar, right? So here, the shape will be similar. So if this is y equal to 1 over x cubed, right? So it's still the same here. The cube you're going to have, right? So in here, you will have a little bit more flat, go down here. So it's a very similar shape. Then here you have a little bit more flat going down here. So for the cube, it's the same here. So like it's a little bit more flat. All right, so this is y equal to 1 over x fourth here. So whenever you see this one, then you recognize, you say, hey, this is, you know, and this is what we call is reciprocal function. Okay, so the last two functions, I hope I have space. One is the absolute value function. Okay, so for the absolute value functions here, so we use y equal to the absolute value of x, and this will also, we call this the parent functions, right? This will be the parent functions for the absolute value function. So remember, for the absolute value function, the function, what is going to looks like is a V shape, right? So the absolute value function going to be look like a V-shaped functions here. So the absolute values always have a sharp corner here because of V shape. And we're going to talk way more details about that. Okay, so the next ones here, we call this the greatest integer function. Okay, so the greatest integer function, we use this notation, f of x is equal to kind of a bracket, right? But it's not a really bracket. You have a bracket and then you have one extra line there. So the greatest integer function, sometimes we also call is the step functions here. It's like a step. Okay, so then in here, that's what is this one going to go here. So it's like you always have a solid on the left, and then here is a circle, and then you jump. Okay. Right, so that's what is we call this, the step function. If you don't remember the greatest integer functions, and you might want to go back to review a little bit about your algebra 2, how do we find the greatest integer function? And later, if we're going to talk about it, use it, we're going to go over again. So not a big deal. And if you right now you don't quite remember that, but just remember what is the shape, right? Like I said, this section, the purpose here is not to go over the detail, just let you know when you recognize the shape, you know what type of function you are dealing with, okay? So the name here, and we're going to do, how do I plot the piecewise function? This is a very important function here. We call it piecewise. That means the function has to be, like in this one, instead of say f of x equal to x squared or fx equal to 1 over x, they have two pieces here. So one is x squared, and the other one is 2x plus 1. So the key for trying to graph the piecewise function is you always need to graph where they break. Did you see that? So you always has to graph where you break. So like in here, okay, so let's try to graph here, right? So I break at x equal to 1, right? So I'm going to graph the x squared here. And the first point I'm going to see here, I always need to graph at where it's going to break, where the function break, right? So when x equal to 1, what is the f of x squared going to equal to? So if this is equal to my f of x, so what is the one here? It's 1, right? Right, it's x squared. So what you do here, you go here, because this equal signs here. So when x equal to 1, y equal to 1. Did you see that? So you need to have a what here? And what type of it has to be what? Has to be a solid, correct? Did you get that? So the reason why is it has to be a solid. Okay, so sorry, I did so 1 and 1, I did graph the wrong place here. Okay, so x equal to 1 and 1, so it's here. I'm sorry here, right? So this is, so it has to be a solid. The reason why it's solid is because I have equal signs, right? And then I know, oh, the x squared. So what I know is x squared is quadratic, right? So it's so it's a quadratic we just reviewed. So I can choose a few more points. I can say, okay, x equal to 0. Then I said f of x equal to what? Equal to 0. In here, because this piece is x less than equal to 1, so I'm not going to choose anything greater than 1, correct? So I'm going to choose x is less than 1. So now my second point is x equal to 0, y equal to 0. So this is my next point here. Then I'm going to choose another point. I say, okay, I'm going to continue to go to the left-hand side, right? So this is negative 1. So what is the f of x here? The f of x is 1, right? So it's negative 1 when you square. So I don't know why I like disappear. So -1 when you square it is in here. If you want, you can choose one more point because you know it's a quadratic shape. So you can say, hey, let's choose -2. So if you choose -2, what is f of x is -2 to the square. What do you have here? It's 4, right? So you say, okay, 2, 1, 2, 1, 2, 3, 4. So you're going to have points here. So you know, because it's a quadratic, we just reviewed it, but then your right-hand side graph cannot exceed 1. So your graph going to go like this. I hope I can do a good curve draw. So it's kind of difficult to, oh boy. So it's kind of difficult to draw. By using the pens here, right? But you see what that means, right? So here. Not bad, not bad. It's pretty good. If I can erase this one. Oh, okay. So not bad. 2, 4 is here, right? So, okay. What looks like a 3p, but you know this is the, you know this is the, okay, let me see. Let me try one more time. Hope that I can do a good one. I hate this 1, 2, 3, 4. I hate drawing. Oh, better, right? So this one is the x squared. Okay, now I'm going to do my other pieces here is at 2x plus 1, right? So I'm going to do my other pieces here, fx equal to the 2x plus 1. Remember, we always need to plot the point at the breaking point. So this is x equal to 1. When x equal to 1, so what is my f of x? So it's 2 times 1 plus 1. So what is here? It's 3, right? So I'm going to graph it. It's 3. So 1 is 3. 1, 2, 3. But in here, I'm going to graph a circle. The reason why is to graph a circle. 1, 2, why is it disappear here? Okay. The reason why it's a circle because I don't have equal signs here. Okay. And now I can continue to choose the point on the right-hand side of the 2x plus 1, right? Because x greater than 1. So let's say x equal to 2. So what is the x equal to 2 going to be? So 2 plus 2, 2 times 2 is 4. So it's a what? It's a 5, right? Okay, so 2 is 5. So 2 times 2 is 5. So it's a 5 here. Okay, so now I'm going to graph this one here. 2, 1, 2, 3, 4, 5. So it's in here. Okay, now if you look at this, this is the, what here? This is linear functions, right? So I have 2 points, and then I can connect these 2 points, and I can get a lines here, right? So this is my line. So this will be my functions here. Right, so that's the graph for this piecewise function. So remember, when you do the piecewise function, you do the homework, remember, right? You always need to graph the point at the breaking point. What I mean the breaking point is where those functions separate, right? So you need to graph on both. Then you see where is the equal sign there. For the equal sign, you put a solid dot. For the one without the equal sign, you put a circle, just like in here, I put a circle. So that's what is my graph here. Okay, so now let's take a look at the backward one. So the backward, then they said, hey, I give you this piecewise function. Then how do I define it? Okay, so the first ones here, they said, okay, so the first piece is x less than -2, right? So x less than -2, where is that? Oh, here, this is the fine, x is less than or equal to -2. Then you go back to see our graph. What type of function is one? Constant. So we say it's a constant, so it's f of x equal to c. So what is this constant here? Because this is -2, right? So this is -2 here. Okay, now the next one's here. I see here the x greater than 2. So the greater than 2 is this part, right? So this part. Hey, if you take a look from the summary, so what is this one here? This is also is a constant. So what is it here? So it's a 2. Okay, now I'm working on the between here. So it's a negative 2 to 2 because they both have the equal signs, right? So I know that here this is the one. So this is the, okay, so this is the part I'm looking for, right? Right, so this is the part I'm looking for here. So this is the linear functions, right? Okay, so in order to do the linear function, I need to have 2 points. So the first point, this is negative 2, right? So this is my first point here, negative 2 and negative 2. Then the next point here is 2 and 2, right? So this is 2 and 2 here. So I can see the slope, everybody still remember what is the slope? The rise over runs, right? So rise is y2 minus y1, x2 minus x1, so it's 1. So the slope is 1. Then use the slope and the 1 point formula. So y minus 2 equal to 1 times x minus 2. So this is equal to y equal to x. And in fact, we introduce y equal to x is what is our identity functions here. So y, so f of x equal to what? Equal to x. That's how do we write the, from the graph, how do we, how do we write it out? What is my function look exactly like? All right. Okay, so now the next thing here we're going to talk about is vertical line test. So what is the vertical line test? The vertical line test is tell you, if you give me a graph, then I want to see is this graph is a function or not. Remember from the first lesson, we said, what is the function? Every x can only have one y, right? So every x can only have one y. You cannot have one x have two y's here. So what is the vertical test? So let's write it down. So we say a curve. So a curve in the coordinate plane. Okay. Is the graph of a function. Right? If and only if no vertical line, too many if and only if no vertical line, intersect the curve more than once. Okay, so that's what we said. If I want to define, hey, whatever the graph you give me is a function, right? It's a graph of a function. So that means then if you draw a vertical line, so because every x can get only one y, that means you cannot touch the graph more than once, right? So if you touch the graph more than once, what's that mean? That means one x got two y's here, right? So take a look here. So let's take a look at the first ones here. We say, hey, this is a graph or is a function or not. So here we say, hey, if you draw a line here, right? So if you draw lines here, so what happened? This line touch here twice. That means for this given x here, right? How many y's you have? You're going to have two y's here, right? So that's why we say, hey, it cannot happen. So this is not a function. Then the second one is here. If you draw the lines here, so you draw every vertical line. So for example, I draw this vertical line, vertical line, vertical line, vertical line. What happens here? Every vertical line only touch once, right? So this is a function. Okay, so the third one is here. For here, it's the same things, right? You draw every vertical line. So every vertical line you draw only touch once. So this is a function. So the same way here, like if you draw vertical lines here, how many times is the touch here? They touch here, here, here. They touch 3 times. We said every x can only have 1. Now this x has how many? 3. So we said no, this is not. Okay, so the vertical line is very easy, right? Now we're going to look at this type of problem in a different way. Is how about if you give me an equation? How do I know this one is, whenever given x, I have only one y or not? So how do we solve this? So the way we solve this is we solve for y's here. So let's take a look at the part A here. This is 3x squared minus y equal to 5, right? So if I minus 5 plus 5 plus y both sides. So this is 3x squared equal to 5 plus y. Now I minus 5 both sides here. So I have 3x squared minus 5 equal to y, right? So if I can rewrite this, is kind of switch it around. It's easier to see. So that means y equal to the 3x squared. So for any given x, how many value of the y? 1, right? If you give me x equal to 2, right? So I will have 12 minus 5, so 7. So you only get 1 y. You cannot get a 2 y. So this is a function. So the answer is yes, this is a function. Okay, so now let's take a look at this one here, right? So in here, I can plus 4y squared plus 4y squared, both sides. So this will give me 2x equal to 3 plus 4y squared. Now minus 3, both sides. So I have a 2x, right? So 2x minus 3 equal to the 4y squared. Divided by 4, divided by 4. So I have a 2x minus 3 over 4 equal to y squared. Okay, so let's rewrite this. Y squared is 4 to 2x minus 3. Okay, now I take the square roots. So I know every time I take the square roots, I have a positive one. So 2x minus 3 over the y is equal to the negative square roots of the 4. This is a 2x minus 3, right? So whenever you give me an x here, so for example, if you give me x equal to, right? So you give me x equal to 10. Let's just get a 5. It's easier to do. So for example, you give me an x equal to 5. So what happens here? Okay, so if you give me an x equal to 5, this y will give me the square roots of the 4 and the 5. 2 times 5 is 10, right? 10 minus 5 is 7. So it's 7 over 4 square roots. Now what happened to this one? The y is equal to the negative 7 over 4 the square roots. So I know for every given y, how many y's I have? 2. So this is a function? No, this is not a function. Okay? Okay, so now let's take a look at the last ones here. So these ones here, I can say I can minus 2 absolute value both sides. So I can get a y is equal to negative 2x value, absolute value of x. So whenever given x, how many y I have? 1s, right? So for example, if x equal to 2, what happened here? Y is equal to negative 4, right? So if I get x equal to negative 2, y equal to negative 4, it's okay. We know a function, the different x values can go to the same y, but one x cannot go to 2y. So this is a function? Yes, this is a function because for every given x, I only have one y. Even like right now, for the two different, the two different x's here, I have the same y. That's okay, right? So still it's a function, like the example we talk about, if you remember on the first video, we talk about like the boys invite a girl to the dance, right? So like 2 boys can invite the same girls, right? So 2 boys, they can invite the same girl, just like the boy number 2, boy number negative 2, they can invite the same girl. That's fine. But 1 boy cannot invite 2 girls because You don't know. You know, if they both say yes, then who you go dance with, right? Okay, that's it. That is for this sections here is what type of the graphs looks like. So let's summarize what are the key things here. The key things here is you need to remember, right? So go back to the first pages here. You need to remember those are the few basic functions we're going to work throughout the semesters. So right now for here, you just need to recognize the shape, and then you know what type of the function. Then the next thing here is try to graph the piecewise function is quite important. The key things to remember is what? You always need to graph the point at the breaking point, all right? And then how to go backward if they give you the piecewise function, and how do you find the function itself? So you need to reference back to the function graph to see which function you can use, right? Now we talk about the vertical line test. The vertical line test, the graphic part is pretty easy. But now if they give you a function, you want to decide it's a function or not, and then you need to solve for y's, right? After you solve for y, and then you see, hey, for any given x, do I only get one y value or not? All right, that's it. And hope you get a good understanding about these sections here. And don't forget to do your homework assignments so you can be good at it. So you practice and you can be good at it. Okay. So it's nice to talk to you, and have a good day. All right. Bye.